Alright, 8.3, day 2. Going to take a look at two problems for you. We're going to do one problem where they ask you to use the formula for a 2 by 2 matrix to find the inverse. You remember seeing it in the notes. If not, you can see it's in your textbook or in the notes. But we're going to specifically use the formula instead of using a Gauss-Jordan system to solve. And then we're going to solve this system by using an inverse matrix, and it's important that you catch that. It's going to be a little bit longer in the process that we do, but this is what they want us to do. Alright, so back to the first one. They want us to use the formula to find the inverse of a 2 by 2 matrix. So I have to remember the formula for that inverse, and it's 1 divided by AD minus BC times, and then it's D negative B negative C A. Or in other words, what you're doing is, you might remember we called this the determinant, where you multiply these two numbers together to get A and D, because this is A, B, C, D. Subtract whatever you get when you multiply B and C together, so it's 1 divided by that number, times, and then if you pay attention to pattern, remember this is A, B, C, D. A and D change places, so the negative 12 and the negative 2 will change places, and then B and C are these two numbers, they switched sign. Doesn't mean that they're negative, it just means that they switch sign. So if they were negative, they become positive. So to do this, it's going to be 1 divided by A times D. It's negative 12 times negative 2, so it's going to be positive 24, minus B times C is 15, times, now remember A and D switch places, so this is now negative 2, this is now negative 12, and then B and C switch signs, so it was positive 3, so it now becomes negative, was positive 5, it now becomes negative. And now I just have to distribute 1/9 in here. And so it's going to end up giving me, the first number would be negative 2/9. Second one, if I distribute, would be negative 3/9 or 1/3. Then negative 5/9 and negative 12/9 or negative 4/3. And that is the inverse of this 2 by 2 matrix. If you can remember this formula, it's very quick, easy to do, and you don't have to worry about trying to go through the Gauss-Jordan with those fractions. Not that it's that difficult with a 2 by 2 because there's not a lot of steps, but it's obviously a little quicker if you can remember that. It only works for a 2 by 2. Alright, this one, asking us to solve. Now if I was going to just solve it and I didn't pay attention to this using an inverse matrix thing, what I would do is I would do my normal Gauss-Jordan. I would set up the augmented matrix. I would use just negative 1, 2, 0, and I would go through and I would solve it. Because they're asking me to solve using an inverse matrix, remember what we did in class. We said that we used, I called it the variable matrix, matrix A, which represents the coefficient matrix over here, times the variable matrix. So coefficient matrix times variable matrix is equal to, I think I said that backwards before, is equal to what we called the answer matrix, or B. So if I was going to actually write this out, I would say that it's my coefficient matrix, which is 1, 1, 1, 3, 5, 4, 3, 6, 5, times the variable matrix, which is x, y, and z, is equal to the answer matrix, which is negative 1, 2, 0. So if I switch it to a matrix equation, well, I'm trying to solve for my variable here. And if you're looking at this, you'd say divide by A. You don't divide by matrices, you multiply by its inverse. So I need to find the inverse of this and then multiply. So the idea is simple enough. It's figure out what the inverse of this coefficient matrix is, which I don't know off the top of my head. So I'll just do that. Figure out what the inverse is, and then multiply it by negative 1, 2, 0, or the answer matrix. And you say, well, how do I know whether to do it this way or reversed? Look at the dimensions. If I tried to do it the other way around, if I flip these over, the inside numbers wouldn't match. Here they do match, so it's got to be like this. So that's the idea of what I'm trying to do. So it's going to take a little bit longer than just doing Gauss-Jordan, but it works out. So my step or my goal is I need to figure out what the inverse of this matrix is. So I'm going to go ahead and write down my augmented matrix with the identity matrix on the side. I've got 1, 1, 1. Remember to put my row of dots and then the 1, 0, 0. I have to do that first before I do any kind of changing. Not that I would want to change these around. Filling in my coefficient matrix, I've got 0, 1, 0, 0, 0, 1 there. I've got the identity next to it. Now I run through and try to find the inverse. So remember to show all of your work and show steps. Looks like I'm going to have to multiply by negative 3 for both of these. So negative 3 times row 1 plus row 2, and negative 3 times row 1 plus row 3. keeping the top row the same since I've already got the 1 in the x position. Alright, so multiply by negative 3 and add is going to give me 0. Multiply by negative 3 and add should give me a 2. Negative 3 and add 4 should give me 1. Negative 3 and 0 is negative 3. 0 and 1, and then 0 and 0. And then go back and do the same thing for this row. It's negative 3 plus 3, so 0. Negative 3 and 6, which gives me 3. Negative 3 and 5, which gives me a 2. Negative 3 and 0. 0 and 0. 0 and 1. So there's my first step. Got the 1, got the zeros. Now next step, I want to try to get a 1 using those two. So I think I can look at those and see that, yep, if I would subtract those two or multiply the second row by negative 1, that would definitely give me the 1 that I'm looking for. So that's what I'm going to do. Again, you can write it however you want. I write it as negative row 2 plus row 3. Same thing if you just say they're subtracted. Just be careful with your negatives. And it's 3 minus 2, so 1. 2 minus 1 or 1. Negative 3 minus a negative 3 or plus 3, so 0. 0 minus 1, and 1 minus 0. And then remember, I used both the second and third rows to get this equation, so it's my choice which one I want to use. Here is my third row, and I'm going to use the second one. And again, the only reason I'm picking that is because it's got a smaller number. Otherwise, it doesn't really make a difference what I do. Alright, so next step, again, copy down the first row. Copying down the second row now that I've got the 1 in the y position. Whoops, that's a 1. 0, negative 1, 1. And now it looks like I need to multiply by negative 2 to get rid of that 2. So negative 2 times row 2 plus row 3. And that gives me the 0 that I'm looking for here. It's going to be negative 2 plus 1 or negative 1. So I'm going to write that very lightly because this is going to be easy fix. I just have to multiply everything by negative 1. So right now I'm writing all these things really lightly. That's going to be 0 or negative 3 if I add. It's going to give me positive 2 plus 1, so positive 3, negative 2 plus 0, or negative 2. And now to fix this, I'm just going to say I'm dividing or multiplying by negative 1, so this will now give me a positive 1. That would become a positive 3, negative 3, positive 2. If you prefer to write another step, that's fine. Something this simple, I would probably just do this. Alright. And now let's use this one and get rid of those two ones. So copy down the last row now. I have multiplying by negative 1, adding to this will give me the 0 that I'm looking for. Negative 3 plus 0, so negative 3. That becomes positive 3 minus 1, or 2. This becomes negative 2 plus 1, so negative 1. Negative 1 multiplied again to get rid of that one will give me negative 3 plus 1, so negative 2. Will give me a positive 3 plus 0, so positive 3. Negative 2 plus 0, so negative 2. And now I have the 0 here that I was looking for. One last step, use that one to get rid of this one. So copy down now the last two rows as they are completely finished. Alright, and now multiply by negative 1, so negative 1 times row 2 plus row 1 is going to give me the 0 I'm looking for. That'll stay 0. That becomes positive 3 minus 2, or positive 1. That becomes negative 2 plus 3, or positive 1 again, and positive 1 minus 2, or negative 1. And now here is my inverse. And according to what we were saying up here, I'm going to take the coefficient matrix inverse, which is what we just found right here, and multiply it by the answer matrix. So I'm going to take this inverse, which is 1, 1, negative 1, negative 3, 2, negative 1, 3, negative 3, 2, and multiply it by my answer matrix, which was negative 1, 2, 0. And if you look at the dimensions again, it's a 3 by 3. 3 by 1, the inside numbers match. I'm going to end up with a 3 by 1. And I've only got one column, so multiply row by column to get this number. It's negative 1 plus 2. That 0 is helpful. That means I really don't even need to look at that last row or that last column. So it's negative 1 plus 2, or that should give me 1. Here it looks like I get positive 3, positive 4, 0. Add those numbers together gives me 7. Negative 3 minus 6 plus 0 is going to give me negative 9. And so my answer is 1, 7, negative 9. I said, is this the most convenient way to do it? No, if I said to just solve it using any method you wanted to, you would have been better off to do this, where you actually put the answer. So I'd have put negative 1, 2, 0, and then just went through and did my Gauss-Jordan. That would have been much quicker. This asked me to use an inverse matrix, so this is what they want. And you would have to find the inverse. Now, of course, the idea behind this is, why would I do something that takes longer? Well, the idea is, of course, I can do this with a calculator. That's the main idea for using matrices. That's why we did all this Gauss-Jordan stuff, so that we could figure this out. So once I see this problem, I could say to myself, okay, I need the inverse of this. So all I really need to do is type this in my calculator. So second x to the negative first, go over to edit, pick whichever one you want. The first one, it's a 3 by 3, so make sure you got the dimensions correct. Enter in the first row, which is 1, 1, 1, then 3, 5, 4, and then 3, 6, 5. And once I have that in, I can go ahead and leave. I am going to need the answer matrix because eventually I'm going to need to multiply by it. So I'm going to go ahead and type that in. So second x to the negative first again. Go over to edit. Do not pick whichever one you just entered this one in. So go down to B or C or whichever one you want. This is a 3 by 1. And then it's negative 1, 2, 0. And now that I've got them both entered in, I simply just need to do this. Now I don't actually need to see this inverse. I just need to go to second matrix, under names, pick letter A. I can simply do that. That'll tell me that it's this. Don't have to actually figure it out. If you want to, you can take the little negative, you can hit enter right here and see it, but you don't have to. Times, go back into your matrix category, pick matrix B, and now it's going to do the same thing that I did algebraically here. Hit enter, and sure enough, it gives me the 3 answers. And realistically, that's the idea that you want to be able to do. If there's a calculator part, that's exactly what I would want you to do, because this is going to take you too long. Alright, that is homework help for 8.3 day 2. If you're having trouble, please come in and ask for help.